Welcome to EDU World Space.
Welcome. All right, we have in number 2 here, chapter 4, number 2. Forgot to write that down. We're looking at 3 vectors, and task number 1 is to find the x and y components of all 3 vectors. So let's start with this 985 Newton vector. The x component points straight along the x-axis like that, and the y component we can draw in right here going straight up. So here is x, here is y. We have made a right triangle, so we can use sine, cosine, tangent, trig functions. I am, let's say, looking for the x component here. The x component is the side adjacent to the 31-degree angle, and the hypotenuse is the force, 985 newtons. So we can find the x component using the cosine, because it's adjacent and hypotenuse. So the cosine of our angle, which is 31, is equal to the side adjacent x divided by the hypotenuse, 985. Solving for x, we've got the hypotenuse times the cosine of 31. And that gives us approximately 844.3 newtons. And that's pointing to the right, so let's just go ahead and slap a positive on there. Okay, similar process is going to give us the hypotenuse times the sine of 31, because our y component is the side opposite in this triangle. And we put that in the calculator for 507.3 newtons. And that component is pointing straight up, which again is in the positive direction, so let's slap a positive on there. Now we're going to do similar things to find the components of our vector right here. We've got one component that points straight up, and we have the x component that is pointing to the left. We do need to be careful with the x component because it's pointing to the left. That's going to give us a negative component. So now let's do the y component here first for this guy. In this case, the y component is the side adjacent to the triangle that I drew. So we are going to use the cosine for the y component, whereas we used the sine for the y component in the previous one. But again, we have the side adjacent, we have the hypotenuse of the triangle, that's cosine. So hypotenuse, 788, times the cosine of the angle, 32, is going to give us the y component on this guy, which is going to be 668.3. And that is the y component of that vector. It is pointing in the positive direction, so let's slap a positive on there. Now for the x component of that vector, which is right here, that's the side opposite 32. We've got the hypotenuse, so let's go ahead and use hypotenuse times the sine of 32 to get our x component. And we end up with 417.6 newtons, and that is pointing to the left, so let's slap a negative on there. There are other ways to get that negative, but this is my favorite. Let's go ahead and now do the 411 Newton vector. We have our y component pointing straight down. Actually, let's not do it that way because we're given the 53-degree angle over here. So let's instead do this triangle. We've got the x component pointing that way. We've got the y component pointing straight down. So let's attack the x component first. That is the side adjacent to 53, and we have the hypotenuse. So hypotenuse times the cosine of 53 is going to give us our x component, and that is going to be 247.3, and that's in the negative direction. And then our y component is going to be the sine. So 411 sine of 53 is going to give us 328.2. And the y component is pointing down, so we need to slap a negative on that one as well. All right, so to recap here, we are looking at the x component, y component. We are looking at, we reversed them, y component, x component here. And we are looking at x component and y component here of those 3 vectors. Part B wants us to find the magnitude and direction of the resultant force. We're adding all three of these forces together. So it's pretty simple. Let's take this x component, let's take this x component, and let's take this x component. We're going to add all of those together, just straight up addition. And so our resultant vector, we'll call this the net force, or the sum of all of the three forces acting, is going to be 179. And that is a positive. I'm going to use vector notation here, the unit vector I hat, to denote x component. We do the same thing with the y's. Let's add up this y component, this y component, this y component, and we end up with 847.4. So we're going to do a plus 847.4 newtons. And that is going to be our j hat unit vector. That's the y component. All right, so we found the x component, found the y component. We have not found the magnitude and direction of the net force. So we've got 179.4. I forgot the 0.4 there. This is 179.4 I hat. So 179.4 going to the right because it was positive, and then we're going to have 847.4 going up. Our x and y components will always make a lovely right triangle when we add them together tip to tail. So this is what we're looking for, the magnitude of the resultant. It's a right triangle, so we can go ahead and Pythag to get the magnitude of the resultant. So that's just Pythagorean theorem, and it's going to give us 866.2 newtons overall for the length of this side of the triangle. And then we're also looking for the direction of this net force. So that's that angle in the triangle. So one way we can do it is the side opposite divided by the side adjacent. That's a tangent. Go ahead and do the inverse tangent of opposite over adjacent, and that is going to give you the angle. So this angle right here in proper math notation is 78 degrees. So the net force is 866.2 newtons. That's 78 degrees. I recommend anytime you have to add up more than two vectors, you find the components first, add all the x's together. That's going to be your x component of the overall vector. Add all the y's, that's going to be your y component. And then just make a final triangle. That right triangle is going to give you the magnitude and direction. Magnitude is that, and direction is that.